So the function value of f underscore value and its derivative f underscore from are calculated at the current guess y. Citation 3. So the guess y is updated using the Newton's method formula. Y equals y minus f f prime citation 3. So the code checks for convergence by verifying if the form of the delta is less than the tolerance tau. So a convergence is achieved, the loop is exceeded, the iteration count iteration is incremented. So nested function to calculate the derivative numerically. So the function calculate derivative calculates the numerical derivative of the input function the point by using a small increment h. So creating the M script. So this one, put this code so na okay. Let me save this. This one. So put all this code on so put all this code in the mem script or suite of script. Okay, this one it shows. So let's proceed to the next. Wait, put all this code and produce a variable within the answer. So function call. So root iteration. So equals Newton underscore method my func a and b. So it calls the Newton underscore method function with the defined function, matrix, vector, and tolerance to find the root and the number of iterations. So display results. What is the display results for this? So the code displays the approximate root and the number of iterations taken to converge. Citation semicolon 3. So we're going to the next questions to be answered within the video. Suppose the tolerance is set default by maximum. What can you do? So how would you modify your code such that the nmax or the maximum iteration will terminate the program and display the result? So the proprietary could already implement this. So the loop includes a check if norm close parenthesis delta greater than tol break semicolon, and which stops the iteration if convergence is achieved before reaching the maximum number of iterations. Close parenthesis and max citation semicolon 3. Also the for loop for I equals 1 semicolon n ensures that the iterations stop when nmax is reached, displaying the result even if a convergence hasn't occurred. So The next, what can you conclude from this activity? So I can conclude for this from this activity. So first is first is first is the implementation of Newton's method. So you can successfully implement Newton's method in MATLAB to find the roots of a given function. Second is the importance of tolerance. So the tolerance value affects the accuracy and the number of iterations required to converge. For 3, limitation of maximum iterations. Setting a maximum number of iterations ensures that the program terminates even if the method does not converge, preventing infinite loops. So, convergence. Newton's method converges rapidly for well-behaved functions but may not converge or may converge slowly for other functions. For the last, numerical derivative. Numerical derivative calculation provides a practical way to implement Newton's method when an analytical derivative is not available. So, that's for today. Thank you for the listening.